Verify that the tangents to the circle x squared plus y squared equals to 5 at the point 1 comma negative 2 also touches another circle. And we need to find out the point of contact of the second circle. Let us begin. So here we have a circle. Let's say it is centered at C1. Now we have a line which is tangent to the circle at point A with the coordinates 1 comma negative 2. We need to show that this same line is also tangent to another circle which is centered at C2, and let's say it is tangent to the circle with center C2 at point B. We'll need to find out the point of contact, that means coordinates of point B. That's our goal. Let us begin. So we'll start with the equation of the circle C1 and the tangent. So we'll try to find out the equation of the tangent using the equation of the circle C1. So here we have this circle x squared plus y squared. So let's do one thing. We'll transpose the 5 from the right hand side to the left hand side and write it as negative 5 equals to 0. The reason why we're doing this, we're going to compare it with the general equation of a circle. So that's given by x squared plus y squared plus 2 times gx plus 2 times f times y plus c equals to 0. So if we compare this equation with x squared plus y squared minus 5 equals to 0, so we will obtain this g value to be 0, f will be 0 as well, and c value will be negative 5. Now we can find out the coordinates of the center of the circle. So coordinates of the center C1, that's going to be negative g comma negative f, which means that C1 has the center at the origin 0 comma 0, and the radius of the circle is given by the square root of g squared plus f squared minus c. So since g and f are 0, we are only left with the value negative c. C is negative 5, so negative c will be positive 5. Our radius comes out to be 5 units. So if we join point C1 and the point of contact A, so C1A, this is going to be the radius of the circle with 5 units. Now, how do we find out the equation of the tangent line? Now here we will be using the point form. So the point form of a tangent line is given by x1 plus y1 plus g multiplied to x plus x1 plus f multiplied to y plus y1 plus c equals to 0. Now here x1 comma y1 is nothing but the point of contact. So x1 comma y1 corresponds to point A with coordinates 1 comma negative 2, which means that x1 will be equals to 1 and y1 will be equals to negative 2. So let's substitute the value. So we have x, then we have in place of y1 we have negative 2, so we have negative 2y. Now g is 0, f is 0, so the third and the fourth term goes to 0. We are left with positive c, so c here is negative 5. So this is going to be the equation of the tangent. This is our equation of tangent. We have to show that this particular tangent is also a tangent to the circle with center C2. So let's use the equation of the second circle and we'll try to find out its center as well as radius. So if we compare this equation with the general equation, then 2g will be equals to negative 8. 2f will be equals to 6 and the c value will be 20. Now g comes out to be equals to negative 4, f value will be positive 3. Now the coordinates of the center C2, that will be given by negative g comma negative f, meaning our coordinates of center C2 is going to be positive 4 comma negative 3. So we have the coordinates of C2 now. So what we will do, we will this is the point of contact, point B. We're going to drop, let's find out the radius of the circle as well. The radius R2 is going to be equals to, we'll take the square root, we'll take g squared, add it to f squared, and from it subtract the value of c. So g squared will be negative 4 squared, so that's 16. F squared will be 3 squared, so that's 9. And c value is 20. So here we have 16 plus 9, that's 25. 25 minus 20 will be 5. So our radius will be square root of 5. We'll keep this aside. Now, what we'll do, we'll try to drop a perpendicular from point C on the straight line. So this is our straight line whose equation is x minus 2y minus 5 equals to 0. And we will try to find out the perpendicular distance, because we know that if we have a point, let's say with the coordinates x1 comma y1, and we have a straight line whose equation is given by ax plus by plus c equals to 0. So if we drop a perpendicular from that point on the straight line, then this perpendicular distance will be given by the formula ax1 plus by1 plus c whole divided by the square root of a squared plus b squared. So this is how we can find out the perpendiculars. So using this formula, we're going to find out the perpendicular distance C to B. So here we have the equation of the line. So let's find out the perpendicular distance C to B. So this will be equals to, we'll take the absolute value. So here we'll take the ratio. First we will need the coefficient of x. The coefficient of x is 1 here. The 1 will get multiplied to the x coordinate of the center C2. That's 4. Added to, we'll take the coefficient of y. So that's negative 2. Negative 2 will get multiplied to the y coordinate of the center C2. So that's negative 3. And then we add it to the constant term. So that's negative 5. And we are going to divide it by the square root of, we'll take coefficient of x, which is 1, square it, and then add it to coefficient of y, which is negative 2, square that value as well. Let's compute this value. So we get 4 plus 2 times negative 2 times negative 3, that's 6 minus 5, divided by square root of 5. So 6 plus 4, that's 10. 10 minus 5, that will be 5. So we're 5 over square root of 5. So if we rationalize the denominator, we're going to get square root of 5. So that means our perpendicular distance C to B comes out to be square absolute value of square root of 5. We'll take the positive value to get square root of 5. Now this is exactly equals to the radius R2. The radius R2, which tells us that indeed the line whose equation is x minus 2y minus 5 equals to 0 is also going to be a tangent to the circle with center C2 at point B. Okay. Now our next goal will be to find out the point of contact B. We will assume that its point of contact, let it be x1 comma y1. Now if it is x1 comma y1, this particular point is lying on the tangent line. So we can replace the value of x with x1 and y with y1 in the equation of the tangent. This is going to now give us x1 minus 2 y1 minus 5 equals to 0. And also the point x1 comma y1 lies on the circle with center C2. That means we can replace x with x1 and y with y1 in the equation of the circle to get x1 squared plus y1 squared minus 8x1 plus 6y1 plus 20 equals to 0. To find out the value of x1 and y1, we will solve these two equations. So this is a very simple task. So here we can rewrite x1 as 2 times y1 plus 5. And we will replace this value of x1 into the equation of the circle. So we get, in place of x1, we have 2y1 plus 5 whole square added to y1 square minus 8 multiplied to x1. So we're going to replace x1 with 2y1 plus 5 plus 6y1 plus 20 equals to 0. So expanding 2y1 plus 5 whole square, we're going to get 4y1 squared plus 20y1 plus 25 plus y1 squared minus 8 times 2y1 will be 16y1 minus 8 times 5 will be 40 plus 6y1 plus 20 equals to 0. So 4y1 squared and y1 squared, that's going to be 5y1 squared. Then we have 20y1 minus 16y1, so that's going to be plus positive 4y1. So that added to 6y1 will make it 10y1. Now we'll add up the constants. So 25 added to 20 will be 45. 45 minus 40, that's positive 5 equals to 0. We can factor out 5 to get y1 squared plus 2 times y1 plus 1 equals to 0. This is nothing but y1 plus 1 whole squared equals to 0. So we get the value of y1. So y1 comes out to be negative 1. And we will substitute the value of y1 with negative 1 in this equation. And this gives us the corresponding value of x1. So x1 is going to be 3. So that means we have the coordinates of the point of contact B. So that's going to be 3 comma negative 1. So we have successfully found out the point of contact of B. So that's 3 comma negative 1, and we have also showed that this particular line is tangent to both the two circles.